Good morning, everyone. So today is March 25th. It is Wednesday. Um, so we're going to be going through, I'm going to try and get through the rest of topic 7's study guide. Now, there are some things that I skipped in class that I'm going to go over here. So this may be a particularly long video simply because we're going to learn some things that we may not have gone over before. So, I said yesterday that we went through 1 through 10B, so we're going to start at 10C and D. Now, I just want to remind you of the instructions for 10 real quick, because directions are important. All right. It is to find the product, which means multiplication, and using box method of the two binomials. So let's go ahead and start 10C. So this says 8m plus 3 squared. Well, 8m plus 3 squared really means 8m plus 3 times 8m plus 3. And we're actually going to use this to go ahead and just do our box method. So box method starts by figuring out how many, or the dimensions of our box. So notice that 8m plus 3 has 2 terms, so it's going to be a 2 by 8m plus 3 has, again, 2 terms, so it's going to be a box that is 2 by 2. So let's just draw a 2 by 2 box. I'm going to put the first binomial, 8m plus 3, on the side, and the second binomial, 8m plus 3, on the top. And I'm going to go ahead and simply multiply like I did yesterday. So 8m times 8m, well, 8 times 8 is 64. M times m is m squared. All right, 3 times 8 is 24, and with an m. 3 times 8m is, again, 24m. And 3 times 3 is 9. So what we can do right here is we can go ahead and say, all right, we know that this equals 64m squared plus 24m plus 24m plus 9. The last thing we have to do is make sure that any combined or any like terms get combined. We know that 24m and 24m will combine. So 64m squared is going to stay. 24m plus 24m is 48m plus 9. That's it. We're done. That's all 10C had to offer. All right, let's go ahead and do 10D. And again, when we're looking at this little square right here, make sure I can highlight that for you. We know that that actually means times itself. So we're going to do 5y minus 6 times 5y minus 6. And again, box method, I'm going to go ahead and figure out how many terms there are in each of these. So 5y minus 6 has 2 terms, and 5y minus 6 has 2 terms. So this box is going to be a 2 by 2. And we're going to put the first binomial on the left and the second binomial on the top. All right. And again, we're really just practicing this multiplying. All right. So 5y times 5y. 5 times 5 is 25. Y times y is y squared. Negative 6 times 5y is negative 30y. Negative 6 times 5y is negative 30y. And negative 6 times negative 6, negative times negative is a positive. 6 times 6 is 36. So we have 25y squared minus 30y minus 30y plus 36. If I'm going too fast for you, or maybe you're not remembering why I'm doing certain things, please go ahead and check out the video for 1 through 10B. That will make everything much more clear if you are forgetting a step or two. All right, and the last thing I want to do for this one is simply combine like terms. I know negative 30y minus 30y, they're like. So 25y squared gets pulled down, doesn't change. Negative 30y minus 30y is actually negative 60y, and the 36 does not change. So that's 10C and D. All right. 10E and F actually showcase this little trick. Now, this is one of the things that I said we really didn't go over in class. Now, the reason we were actually running out of time with dates and things like that, so I had to cut some stuff. But since we have time now, I figure, why the heck not? All right, so let's go ahead and we're going to cover E, x minus 3 times x plus 3. I want you to notice that x minus 3 and x plus 3 look very similar. The only main difference they have is the sign in between the x and the 3. So we're actually going to do this like normal, and then I'll show you how it's so special. So box method, we're going to count how many terms there are in each polynomial. So x minus 3 has 2 terms. X plus 3 has 2 terms, so we're going to make a 2 by 2 box. And we're going to put the first polynomial on the left and the second polynomial on top. And just multiply them just like normal. X times x is x squared. 3 times x is 3x. Negative 3 times x is negative 3x. And negative 3 times positive 3 is negative 9. All right, again, write it out like you're reading a book. X squared plus 3x minus 3x minus 9. All right, do the same thing that we did in 10C and 10D, which is combine like terms. And here is where stuff begins to happen. So I asked you to look at the symbols in x minus 3, x minus 3 and x plus 3. They're opposite. Well, what happens with that? When they're identical terms except the symbol is a negative and a positive, what's going to happen is you have a positive 3x, a negative 3x. 3x minus 3x is 0. So we don't actually have to write this. This actually cancels out, and we're left with x squared minus 9. Now, I know what you're thinking. So what? Well, because we can do this way, we figure out that if it's x squared minus a number, we can actually figure out what the square root of that number is. So the square root of 9 is 3. And we can actually rebuild it, or we can go backwards, and we can say, okay, well, I know that because it's only 2 terms, x squared and a negative 9, that it must be an x minus 3 and an x plus 3. This rule actually holds. So we'll see this in a few other places, but when we see it, I'll come back and reference 10E. So I know what you're thinking right now. F sure looks a lot like E. So notice it's 7y plus 9 times 7y minus 9. So really what we're looking at here is I'm gonna take a shortcut. Notice that the first term in E just squares. So x times x was x squared. So what we're gonna do is, and try and follow me along, this is something new. We know that these 9s are going to cancel in that middle term. So we're just going to go ahead and do 7y times 7y is 49y squared. So we're going to say 7y times 7y is 49y squared. All right. Now, because the middle term is going to get canceled, we don't need to worry about any term in the center. We know it's actually going to just be a 0. So we're going to focus on the last term, this positive 9 times this negative 9. Positive 9 times negative 9 is 81, negative 81. So our answer can literally look like 49y squared minus 81. For those of you who don't like that shortcut, I'll quickly just write the box method so you can see and realize that this shortcut may be easier, but maybe it's just nice to stick with what we know. So I'll do a 2 by 2 box because there are 2 terms in each polynomial. And this is really just double checking that this shortcut works. 7y plus 9 times 7y minus 9. 7y times 7y is 49y squared. Negative 9 times 7y is negative 63y. 9 times 7y is positive 63y. And 9 times negative 9 is negative 81. Again, I'm going to write this out. 49y squared minus 63y plus 63y minus 81. And notice, if I combine my like terms right here, negative 63y plus 63y is 0. So I can bring down the 49y squared and the negative 81. So doing it the long way and using the shortcut, we get the same answer. This shortcut is purely to show you how to do some of the problems later on, but it is actually really, really nice, especially when maybe you're running out of time on a test or something like that. So let's go on to number 11 and number 12, which is greatest common factor. If you don't remember greatest common factor, what we do is we're going to break each number or each term down. So break, and let me separate this so they look like two different words. Break each term down. And then we're going to find what they have in common and then separate it. So we're going to start with A here. 12x to the third minus 6x squared plus 24x. Well, what I'm going to do is I'm actually going to break 12x to the third down first. So 12, I know, is really 4 times 3. Why does that keep happening? So 12 is really 4 times 3. X to the third is really x times x times x. So I'm going to break this down even more. 4 can really be broken down to 2 times 2 times 3, and the x's remain. Why am I doing this? Well, the reason I'm doing this is because if I break it down to its base factors, I know that I can find everything they have in common and find my greatest common factor at the end. So I'm going to go ahead and break down negative 6x squared. So negative 6 really is just minus 2 times 3. So 6 is really just a negative 2 times 3. Or you could do negative 3 times 2. Or you could even say, and this will get really trippy for some of you, you could even say it's negative 1 times 2 times 3. And then x squared breaks down to x times x. 24 breaks down to 12 times 2. Oh, let's redo that because this is going to take a bit. 24 breaks down to 12 times 2. But 12 can be broken down, and we actually saw that 12 breaks down right here. So I can actually say that 12 is really 2 times 2 times 3, and then times 2. So 24, 2 times 2 times 3 times 2. That's a lot, I know. And for some of you parents who are trying to help, I do appreciate the fact that you may be learning this a new way, and I apologize if this is not the way you've been learning. But guaranteed, this is simple once you get the hang of it. So I'm not trying to belittle anyone. Just make sure that practice makes perfect, and keep giving it a shot. All right. So now that I've broken everything down to its base components, all right, what I'm going to do now is I'm going to circle everything that they have in common. So we're going to start in the first term, 12x to the third right here. And notice each term is separated by either a minus or a plus sign. So what I'm going to do is I'm going to look for any term that they have in common. So first off, I know that there's a 2 right here. There's a 2 that goes into 6x squared, and also a 2 that goes into 24x. So I know that they have 1, 2 in common. So I'm going to go ahead and look at this second 2 right here. If they each have a second 2, then I'm going to circle it. If not, I'm going to ignore that second 2. So 12x to the third has a second 2. 6x squared does not have a second 2, so I can immediately ignore that second 2 and move on to the 3. So let's look at this 3. Does each term have a 3? Well, I know 12x to the third has a 3. I know negative 6x squared has a 3. And I know 24x also had a 3 breakdown into it. And lastly, I want to see how many x's do they share. Well, if we look, 12x to the third has 3 x's, negative 6x squared has 2 x's, and 24x just has 1 x. So I can only circle one of these x's, all right, because even though 12x to the third has these second 2 x's, and this one also has a second x, this one does not. All right, so my last step is literally saying what numbers or what factors did they all have in common? Well, I know each one had a 2, each one had a 3, and each one had an x. All right, so notice that I didn't redraw a bunch of them. Like I didn't draw 3 2s, 3 3s, and 3 x's. It's only what they have in common. So they each had a 2, they each had a 3, they each had an x. So the last thing to do for greatest common factor is literally just say, all right, well, what is 2 times 3 times x? 2 times 3 is 6. 6 times x is 6x. And that's it. We're gonna focus on B now, and I'm gonna go a little bit faster, and I'm gonna use my shortcut. All right, that I taught my students. Now, maybe some of you are like, wait, why are we doing shortcuts now? We barely understand it. Well, I'm going to do my shortcut because it's actually really nice when you have big exponents right here. So if you notice, 11b has y to the 8. I don't really want people on their tests to write 8 y's. All right? I find that a bit excessive. And so instead, I'll teach you the same shortcut. So when we're dealing with variables, so this both terms have an m, both terms have y's. What you're going to look for is you're going to look for the smallest exponent for each of the variables. So let's look at 28m squared y to the 8. Let's focus on just the m right now. It's m squared. Now, negative 49 m to the third y to the fourth has an m as well. It is m to the third. So if we look at just their exponents, we can see that 2 is less than 3. So I know that they can only share at max 2 m's because this m squared only has 2 m's to share. So I know that if I use the lower exponent for each variable, I can actually do that without having to write it out the long way. So I know my answer will include m squared. Now we're going to do this with y as well. That way we have some continuity. Let's pay attention to y real quick. The first term, oh, excuse me here. The first term, 28m squared y to the 8, has y to the 8. The second term, negative 49m to the third y to the fourth, has y to the fourth. So again, 4 is less than 8. So I know that it's going to include 4 y's. So we're going to say m squared y to the fourth. Now that is part of our answer, okay? This is part of our answer. So now we have to figure out what do the leading numbers share in common. Now the leading numbers, 28 and negative 49, we're going to break these down just like we did for 11a. So 28 breaks down to 2 times 14. So I'll just write it here. 2 times 14. Well, I can break down 14 again. I know 14 breaks down to 2 times 7. So this 2 gets carried down. So I know that 28 is really just 2 times 7. Now, negative 49, I don't know if you know this, but negative 49 has a very specific set of factors. It is simply a square. So negative 49 is really just negative 1 times 49, and 49 can be broken down to 7 times 7. So I know that negative 49 is really negative 1 times 7 times 7. And what do these two sets of factors have in common? Well, they both have a 7. So because they both have a 7, I'm going to take that 7 and throw it right here in front. So our greatest common factor is 7m to the second, y to the fourth. That is 12b. Now, Mr. Malott, that was terrible. Why did you make us do that? It is important to find what things have in common. You're going to do that in life. You're going to try and find what things share in common so that maybe you don't have to do as much work later on. All right. So number 12, we're going to factor out the greatest common monomial factor. The thing, though, that strikes me is it says factor out. It doesn't say find the greatest common factor. What it says factor out. We want to find the greatest common factor, which says right here, factor out the greatest common factor. But we also are going to write or keep what is left over. So the first thing I'm going to do is I'm going to do 12a. I'm going to write it out just like I normally do. And then 12b, we'll do it the shortcut way. But let's start with 12a. So I'm going to go ahead and break down 9x squared minus 18x to the third. So I'm going to go ahead and say 9 can break down to 3 times 3, and x squared breaks down to x times x. So notice that the 9 broke down right here, and the x squared broke down right there. And then I'm going to say 18. I know 18 is really just negative 1 times 18, and 18 can be broken down to 9 times 2, and I just broke down 9, so I might actually be able to do this in one go. So I know that negative 18 is going to break down to negative 1, and then 18 will break down to 9 times 2, so we'll say the 2 goes in front, and then 9 breaks down to 3 times 3. And if you're like, whoa, Mr. Malott, I don't understand how you did that, you know what, I'll break it down on the side because maybe I don't think I did too well on that either. So give me 1 second. Let me break down negative 18 because I think it could have been explained better. So negative 18 breaks down to negative 1 times 18. Negative 1 is going to keep getting carried down. 18 breaks down to 9 times 2. And 9 can be broken down to 3 times 3. So this is how it gets broken down. And again, the order really doesn't matter here, but you notice that I have a negative 1, a 2, and 2 3s. X to the third. So I broke down my negative 18. X to the third is simply 3 x's, so it's going to be x, x, x. All right. What I'm going to do now is I'm going to circle what they have in common. So this term, 3 times 3 times x, well, I know that it has a 3 here, and I can see that this has a 3 here. Now going on to my second term, I see a second 3 here and a second 3 here. And then I see that this has 1x, so they both share 1x. And this one has a second x. This one also has a second x. So I know that they have in common 3 times x times x. Now, what is remaining, or what is left over? Now, I call this leftovers. I think every hour I talked about Thai food with them because I had Thai food for leftovers and they all got sick of it real quick. But what we're looking for is what's left over after we circle what they have in common. So if you notice, 9x squared, we actually circled all the factors. The only thing left over is if I said, if I broke one of these 3's down right here to be 3 times 1. That 1 actually stays put. So this is actually considered a leftover. When you circle all of the factors, there is a 1 still remaining. So we know that we have a 1 still remaining for the first term. And if we look at the second term, what's left over is a negative 1 times 2 times x. So negative 1 times 2 is negative 2, and negative 2 times x is negative 2x. So my leftovers are simply 1 minus 2x. My greatest common factors are 3 times 3 times x times x. I want to simplify those. 3 times 3 is 9. X times x is x squared. And we say times our leftovers. So 1 minus 2x. Man, oh man, that is a lot. Well, I know that's a lot. I apologize in advance. Rework it. If you have questions about 12, let me know. We're going to go through 12b real quick. So 12b, we're going to kind of do, you know what, I think 12b, I'm just going to go through the long way as well. I think I'm going to skip that shortcut for now. So 12b, 21ac squared plus 35ac. I'm just going to break it down. 21, I know, is really just 3 times 7 times a times c times c. So 21 breaks down to 3 times 7. The a gets carried down. C squared gets broken down to c times c. 35, I know, is actually 5 times 7. And then the a and c both get carried down. So now I have 3 times 7 times a times c plus 5 times 7 times a times c. So what am I going to do now? I'm going to circle what they have in common. So I see that this one has a 3 right here, but this term over here does not have a 3, so I don't have to really focus on it. This, the second number, 7, this term has a 7. This term also has a 7, so I know that 7 is what they have in common. Both terms, sorry, I don't know what's happening there. Both terms have an A, and both terms have 1c. So I know that they have in common a 7 times a times c. And then we're going to write the leftovers. So what's left over in the first term happens to be I'll do this in green here, a 3c. So 3c plus 5. And I just have to make sure that everything's written as it should be. So 7 times a times c is really 7ac times the leftovers, or my Thai food, 3c plus 5. All right, so that is 12. I will say that 12b is a lot easier than 12a. All right, but let's move on right now. We're going to move on to number 13. All right, factor the trinomial. Now, factoring the trinomial is pretty easy, all right? When we get to number 14, it's going to get a lot more complicated, but 13, let's just focus on 13. So 13 says, factor the trinomial w squared plus 15w plus 14. Trinomials usually come in this form. A times x squared plus b times x plus c. So the first thing I want to do is actually just identify what are the numbers in front of the variables. Okay, so what is a, what is b, what is c? Well, I know that a is right here. And because it's invisible, I actually know that it is a 1. 1 times w squared doesn't have to say, or doesn't have to be stated as 1 times w squared. It can just be w squared. So I know that a is 1. B is where the variable doesn't have an exponent, which is right here. So B is simply 15. And C is where there is no variable, so C is 14. The reason I do this now is because it is good habit to find A, B, and C. So I'm just going to write this on the side. A equals 1, B equals 15, and C equals 14. All right, so when A equals 1, it's pretty simple. When A is greater than 1, that's when trouble starts to come in. So when A is 1, what we can do is we can say, what are the factors of C that add up to B? So factors, oops, my wrist keeps doing this. Factors of C that add up to B. Uh, if you don't know what I mean, I'm going to go ahead and do this right now. So, the factors of C, so C is 14. So there are two sets of factors for 14. 14 can either be broken down to 1 times 14 or 7 times 2. Now, we have the factors of C, but we need to figure out what the factors of C would add up to. So for instance, if we're looking at this pair 1 and 14, we have to say what is 1 plus 14? Well, 1 plus 14 is simply 15. Let's do this again for the factor pair below, 7 times 2. 7 and 2 add up to 9. So I'm trying to find the factors of C, so either one of these pairs, that add up to B. B is 15, so I know that the only pair that adds up to 15 is 1 and 14. So what I can do with that is I can go ahead and make a box method, and we're actually going to do it in reverse. We're going to build this box method. So I know that 1 and 14 are the last terms of the binomials that make up this trinomial. So I know that one of the factors is 1, one of the factors is 14. My last step, or not last step, I guess, but my next step is to simply break down and find the factors of the first term, which is w squared. W squared breaks down to w times w. Well, that's really great for us, so I can go ahead and say w and w right there in our leading terms for our binomials. Now, why did I put this in a box? Well, the reason I put this in a box is so I can check my work, and checking your work is super duper important. So we're going to go through, now that I've gotten w and 1 on the left, w and 14 on the top, I'm going to go ahead and try and multiply this all together to get my original trinomial, w squared plus 15w plus 14. So w squared, or w times w is w squared. 14 times w is 14w. 1 times w is just 1w. And 1 times 14 is simply 14. Well, I'm going to write this out and combine any like terms. So I have w squared plus 14w plus 1w plus 14. Okay, well, I'm going to combine like terms. I know that 14w plus 1w is going to be 15w. The w squared is brought down, and so is the 14. So my checking my work, I know I would get w squared plus 15w plus 14. So my answer is not this right here. That is simply to make sure that I did my work correctly. My answer is actually, sorry, a little glitchy here. My answer is actually these binomials right here. So I know that this is a w and a positive 1. So I know that the binomial would be w plus 1 times w and a 14. So that's actually just w plus 14. So I know that w plus 1 times w plus 14 equals our original trinomial, which means that this right here, w plus 1 times w14, is our answer. It is our factor. Now, why did I even do the box method? To simply check our work. So I'm going to go ahead and do 13b just the same way. I'm going to find a, b, and c. I'm going to find the factors of c that add up to b. So we're going to go over to b right here, put my marker in black. So the first thing I'm going to do is identify a, b, and c. So a is in front of the m squared. Well, that's actually just simply a positive 1. B is in front of m. Well, it's just a negative, and then nothing right there. That's actually going to be a negative 1. So B is negative 1. And C is at the very end. C is actually negative 12. So I know that A equals 1, B equals -1, C equals -12. The first thing I want to do is find the factors of C that add up to B. So the factors of C are actually going to be a little challenging. And the reason they're going to be challenging is because C is negative. -12 is going to have double the amount of factors. I'll show you why. So the first thing we could say is -12 is simply going to be 1 times -12, but it could also be -1 times +12. So I'm really going to have to do twice my work here. So I'm just going to keep breaking this down. It could also be 2 times -6 or -2 times +6. It could also be 3 times -4 or, sorry, why is that not writing? There we go. -3 times +4. So what I have to do for all 6 of these is I have to figure out what would they add up to if I were to add the factors. Because I want to find the factors that add up to B. B is -1. So I want to figure out which ones add up to -1. So 1 plus a -12 is -11. Okay, -11 is not -1. -1 plus 12 is +11. Again, not it. 2 plus a -6 is just -4. -2 plus 6 is +4. 3 plus -4 is -1. Now, I know what a lot of you are thinking. Cool, we found it. Keep working. Keep finding the sums. I've seen a lot of students over my time make very simple errors, and because they stop early, they don't realize that they've made the errors. Let's just check and make sure -3 plus +4 does not equal -1. All right, so -3 plus 4 is actually 1. Okay, good. I know only one of these pairs adds up to -1, which is +3 and -4. So I'm going to go ahead and draw my box now, my box method. All right, box method right here. And I know that a +3 and a -4 are going to be my last terms. My next step is simply going to be breaking down m squared. Well, m squared is really just m times m. So I know that m is my leading term for both binomials. And check your work. Always check your work. M times m is m squared. -4 times m is -4m. 3 times m is 3m. 3 times -4 is -12. And if I write this out, I know it's going to be m squared minus 4m plus 3m minus 12. Combine any like terms. The -4 and the +3m are going to become m squared. -4m plus 3m is just -1m, or simply -m, minus 12. And this should be the trinomial that we were originally given right here. If it is, we know that our binomials right here are correct. And I did get the right trinomial in red, so I know that my binomials m plus 3 and m minus 4 are correct. All right, that's awesome. A lot of work for this one, but once you start getting the hang of it, it becomes a lot quicker. Now, 14 and 15, I'm actually going to save for tomorrow. I know I said I would do some ones that include our shortcut for the ones we did for number 10 up here, 10E and 10F. But this video is becoming pretty long right now, so I don't want to bog you down with too much. So we're going to stop this right here. We'll do 14 and 15 tomorrow, just so I don't burn out some of your guys' brains. All right. If you have questions about the rest of 10, 11, 12, or 13, please let me know. I'd love to help you guys out to make sure that you feel like you understand this. All right, I know that's a lot of work, but go through the video slowly, pause, rewind, as much as you need. Otherwise, I'm happy to make these videos. I will see you all soon. I'm really looking forward to getting back in the classroom because talking to my cats about algebra is not so thrilling as talking to you guys, where you can ask questions, tell me about your day, and genuinely bring joy to my life. So I'll talk to you all later. I'll go live later in the afternoon. Take care, stay healthy, wash your hands, and as always, I'll see you soon. Bye bye, everyone.